In this video, we're going to go over some key algebra equations and how to solve them step by step. By the end of this video, you'll understand the process behind solving these equations and gain confidence in tackling similar problems. If you want extra practice, check the links in the description for my Obsidian notes where you can try out these problems for yourself. Okay, so let's start by describing what an equation is. An equation shows that two expressions are equal. So solving an equation means we're trying to solve the value of the variable that makes the equations true. So let's start with a simple example of this equation x plus 4 equals 10. Now, what value of x would make this equation true? If we were to just guess, the value x equals 6 is the solution because x plus 4 equals 10, right? So the solution is x equals 6. But there are other ways to solve this equation, namely using inverse operations. And so here are the key operations used in equations. These operations should be familiar to you. For instance, we have addition, subtraction, multiplication, division. Maybe you've seen squaring and exponentiation as well. And notice that we have the inverse operations on this side as well. Okay, so the inverse of addition is subtraction. The inverse of subtraction is addition. Okay, so these are two halves of the same whole. Similarly, for multiplication, the inverse is division and the inverse of division is multiplication. Okay, so we're going to use these operations and their inverses to help us solve these equations. So here's some key steps in solving equations. The first step is to simplify both sides by moving the parentheses and combining like terms. Then we have to isolate the variable by performing inverse operations. So if you can't guess, then try using the inverse operations to solve for that term. Then finally, we're going to check the solution by substituting back the original equation. Okay, so for our first problem is solve for x in this expression ax plus b equals c. So here's our x value. We need to isolate x from this equation, right? So pause here and see if you can do this on your own. So notice that we have a constant c here and b on this side here. I'm going to subtract both sides by b, okay, and that's going to allow us to cancel out b on this side. And then we're going to have ax equals c minus b. Okay, on the right hand side, that term becomes a c minus b term. Now we're just going to have ax here on the left hand side, so we just have to divide both sides by a here. Okay, so our final answer is c minus b all over a. So in this example, we need to solve for x. In this equation, 3x minus 5 over 4 equals 7. Okay, so notice that we have 3x minus 5 divided by 4. This entire thing is glued together because of that minus sign. So let's start with here, this 4 here. So we're going to multiply both sides by 4. Whatever you do to one side, we're multiplying the left-hand side by 4. And we have to multiply the right-hand side by 4. Okay, so cancel out those 4's here like so, and then let's rewrite that numerator. There is 3x minus 5 is equal to 7 times 4 is 28, and so we have 3x minus 5 here. So to cancel out that minus 5, we're gonna add 5. What you do to the left hand side, you do to the other. Okay, and so we're gonna again cancel out these 5 terms. That's gonna be equal to 3x is equal to 28 plus 5 is 33, and our final answer is 11. Okay, next up we have this guy. We have to solve for r in 4 pi r squared, and again we don't need to know what these terms indicate yet, but this is the equation for the surface area of a sphere. Okay, so if we were to draw a sphere in 3D space, it might look like that, and we want to basically calculate the total surface area of, let's say, a basketball, right? So that's what this equation will tell us. And we want to solve for r in this expression, so let's just treat all of these as variables. First thing I'm going to do is divide both sides by 4 pi. So I'm going to divide both sides by 4 pi, okay? And so that's going to allow us to cancel out these two 4 pi's here. And so we're going to have this expression on the left-hand side, a over 4 pi is equal to r squared. Now what I'm going to do is I'm going to just rearrange everything. I'm just going to put the r squared over here on the left-hand side and just say that's equal to a over 4 pi. Okay, so not do anything crazy there. And now here we go. We have a square here, and so we need to cancel out this square using our knowledge of inverse operations. And so to cancel out this square, we need to take the square root of both sides. Okay, and that's going to allow us to cancel out our square term there. Okay, and so our final answer is going to be a over 4 pi all over the square root, all under the square root there. Okay, now for this example, we need to solve for c in this expression 3c plus 2 equals 2c plus 5. Now here we go. We have a constant next to a parentheses here, and again we have a constant next to a parentheses here. So what we're going to do is use the distributive property to distribute the 3 to both of these terms here, and in this case here distribute the 2 to both of these terms like so. So on this side we're going to take 3 times c, which is 3c, plus 3 times 2, which is 6, and then we're going to multiply this side. 2 times c is 2c, plus 2 times 5 is 10. Okay, and now we have 3c on the left hand side and 2c on the right hand side, so we need to combine both like terms. So we also have to combine the constant terms here. So I'm going to start by subtracting both sides by 6. Okay, and just rewriting this as 3c equals 2c plus 4. And then finally, we're going to subtract 2c from both sides here. And that's going to give us c is equal to 4. We can check if this is correct by using the value c equals 4 and plugging it into our expression here. And we're going to have 3c plus 2 is equal to 2c plus 5. Okay, and that's going to be 3 times 6 on the left hand side plus 2 times 9 on the right hand side. On the left hand side we have 18, on the right hand side we have 18. So that is correct. Alright, so the very first thing I'm going to do is distribute this 2 into this parentheses here. Let's rewrite the left hand side. 4x minus 3 halves is equal to 2 times x, which is 2x, plus 2 times 1, which is 2. We're going to combine the like terms by doing this all in one step here. I'm going to add both sides. I'm going to add plus 3 halves to both sides. Okay, that's going to cancel out that guy. I'm going to have 4x on the left hand side is equal to 2x plus 2 plus 3 halves, which is, okay, let's do a little side note here. 2 plus 3 halves is the same as 2 over 2 times 2, which is 4 over 2 plus 3 halves, and that's going to yield 7 halves. We're going to write 2x plus 7 halves. Okay, and then we're going to subtract 2x to both sides here, and then we'll get 2x is equal to 7 halves. Finally, we're going to divide both sides by 2 here, and I'm going to multiply by 1/2 because dividing by 2 is basically the same thing as multiplying by 1/2, which gives us our final answer. Cancel out these 2's here. X equals 7 over 4. Okay, now we're getting a little more challenging here. We have 3x minus 2 divided by 4 plus 2x plus 1 divided by 3 is equal to 5. So when you have a large set of fractions like this, the first thing to do is we want to get rid of the fractions. So what do we have down here? We have a 4 and a 3. We're going to multiply by the least common denominator, which is 4 times 3, 12. Okay, so we're going to multiply both sides by 12. And notice that we have to distribute this 12 into both of these terms here. So let's break this down step by step. We have 12 over 4 times 3x minus 2, and 12 over 4 is going to be 3, plus another 12 over 3 times 2x plus 1, and 12 over 3 is a 4, is equal to 5 times 12, which is 60. Okay, and then again, we're going to have to go ahead and distribute each of these terms here. So 3 times 3x is going to be 9x, minus 3 times 2 is a 6, plus a 4 times 2 is 8x, plus a 4 times 1 is 4, is equal to 60. We're going to combine like terms by adding a 6 and a 4. Okay, we're going to add 6. Okay, so these two are going to combine to form a, so our 9x plus an 8x are going to combine to form a 17x, and a minus 6 and a positive 4 are going to combine to form a minus 2 equals 60. And then we're going to add 2 to both sides, so we'll have 17x equals 62. We're going to divide both sides by 17. We can leave our answer in this form, 62 over 17, and that's our final answer. That's fine. Okay, last but not least, we want to solve for v in this expression here, which says d equals vt plus 1/2 at squared. And the reason I put this is because this is an equation in physics, okay? And this equation is used to calculate the distance d in terms of the velocity v and the acceleration a, where t is the time. Okay, so we're going to see this equation again in physics. So we need to solve for v, and we don't care what these other terms are. So I'm just going to group this entire term here and subtract this entire thing, minus 1/2 at squared. But remember, what we do to one side, we do to the other, okay? And so we can essentially cancel out this entire term there. Rewriting this out, this is going to be d minus 1/2 at squared on the left hand side is equal to vt. And remember, we want to solve for v here, so what we're going to do is divide both sides by t, or multiply on this side by 1/t. And we're going to go ahead and distribute this 1/t into each of these terms here. Okay, so on the right hand side, we're going to cancel out our v to get a final answer of v equals d/t minus 1/2 a t squared over t. And notice that this t cancels out, so we can go ahead and just write that as 1/2 at. Okay, all right. Okay, that's the end of this video. If you want access to the written form of these notes, you can access them in the link in the description, where you can see all these for your reference and see more and more practice problems for you to try out. Again, that's in the link in the description. Thanks for watching.